you guys hear me? All good. Yes, as Nathan explained, we have a complete system for 3D.js, and an essential part of that system is analysis in true 3D space. And I'm going to show you a couple of more advanced analysis. This is one we call a volumetric shadow analysis. How's the shadow of a proposed building going to affect neighboring buildings? We've placed that building in our city scene. So here's an example of a building. We place it. We have a look what the visual impact is of that building throughout a cityscape. So we go to another spot here, and we see the building appearing again, and we can get a feel for how that is going to affect our city. But what we can do now, we can actually, for a specific time of day, we can calculate a so-called shadow volume behind this building, which you will see appear now. And that volume we can actually use in further analysis. So we can use that volume to calculate the affected volume of the neighboring building. Now, what we're doing here is something different as to traditional shadow maps you've seen, which is just a visual cue where the shadow goes. Here we're creating features in the database, volumetric features in the database that can be used for further analysis. So again, I'm calculating now for a different time of day the shadow volume of that building. And then I'm going to use the shadow volume to select in 3D all the apartments that will be affected for that specific time of day. Of course, you can do this for any number of times a day and create several shadow volumes and get a good feel of what the effect of the shadow of that building is going to be. So that's one example of a 3D analysis. Another one is what we call a maximum building height analysis. Now, where this comes from is I'm from New Zealand, and they want to know, before they're going to start building, how high can they build according to height restrictions. So what we're doing here is we're going to calculate the maximum height in a certain area that we can build to without that new development being seen from a public road. So what you see here in green is the area of interest. That's where I want to build. And the road with the specific viewpoints are displayed in red. Now, what you can do now, for each point, you can calculate a so-called local horizon and then a visibility plane through that horizon. And I can do that any number of times. So here I'm doing it 6 times. And all these visibility planes from that public road I can use later to intersect in 3D so-called, what I call vertical lines, which are sticks. The reason I'm using here these vertical lines is that actually in New Zealand, they go out and place wooden sticks on the property, and then you have to go drive around and see if you can see these sticks. So I thought I'd use sticks here as well. And I'm cutting these sticks with my visibility planes, you know. And, of course, the more times you intersect, the more accurate your analysis becomes. But in the end, what we're going to end up with is a whole bunch of vertical sticks that can't be seen from, my public road. And the next result we can create from these vertical sticks is actually a volume that can't be seen from the road. Because we're in 3D, we want to have a volume. So what you'll see here now is we're creating a volume from those vertical sticks, which will appear now. So this volume, you can build anything you like in that volume. It won't be seen from the public road. And because in New Zealand they weren't so much interested in as a net result of volume, they wanted to have a height map. What's for each area in that particular property, how high can I build to? Maximum height build. So what you see here is the end result is a map that you can share. And in white is, for example, the areas that you can build to 39 meters maximum. And you won't be able to see it from the road. So just an example of 2 advanced 3D analysis now possible. Thank you.
That's good. So again, the takeaway from this is there are new 3D analytic tools in the product. We're really trying to become more sensitive to the problems that designers and planners have in urban environments, and trying to use the 3D tools in general. What we're going to show you now, you need to switch to your machine. There's a little bit of web editing, and this is based on a little example, a little parable that Jack told us about, which we have extrapolated into a pothole application in New York City. This isn't rocket science, but it talks about the VGI CGM stuff that Mike talked about earlier. And this has been a topic that Jack has really been interested in for a while. So the idea is we have a web-based application. A person could put in a pothole. Now, this could be done with a mobile device. It could be done using a web application. But what he's done is he's actually entered a new pothole. And this is great. We want citizens to be able to do this. But we also want this to go into a database, which has ontology. And we also want to have a management function. So what Derek's done is he's dropped in a few potholes. We can go back and look at them using a manager's view. This is the whole idea. Yes, there's a pothole. Yes, I've got a crew out working on it. Yes, the repair has been finished, and I can publish that out on the public service site. Simple idea, but it closes the whole loop. Okay?